Hi, this is Rob Wallace, broadcasting live from the Distance Learning Studios at the National World War II Museum. And this is one of our series of student webinars that we're presenting this fall. So check our schedule for all of them. You'll see all of them coming up in the next few weeks. I'm going to talk about Niels Bohr today, but first a few details. This is a webinar, so that means that I can't see you, I can't hear you. This helps us keep track of everything and make sure that things are safe. If you want to ask a question, please use the Q&A on the chat, and not the chat, the Q&A, and we'll have somebody monitoring that and sending questions to me. And other than that, I think we'll get started. So I think Niels Bohr is a really cool person to talk about if we're going to talk about World War II, because Niels Bohr was part of almost all the parts of World War II. Okay, so if we could switch to the slides. So Niels Bohr here is pictured with Robert Oppenheimer, who's also a famous scientist from World War II. He was the science director of the Manhattan Project. But unlike Niels Bohr, that was pretty much his involvement in it. Niels Bohr, because of his age and where he lived and just the way he lived his life, he was part of the lead up to the war and all the stuff that happened after the war too. So here you can see him. He's 27 years old. That's his young wife, Margrethe, and he got married to her in 1912. So he married her while he was just a physics teacher at the University of Copenhagen. He was teaching physics to med students, and he didn't like that very much, but he had a lot of time to do his work. Now, if you've taken any chemistry in middle school or high school, you've heard of the Bohr model of the atom. And he invented that. And it started with some papers he wrote in 1912 to 14. He wrote some papers that basically described the model of the atom that we know, where the electrons exist in energy levels outside the nucleus, and that when they change energy levels, they give off radiation, and that radiation is how we can identify sometimes what element we're dealing with. So Niels Bohr married his young wife and was traveling around. Back in those days, there was no email, Twitter, Facebook. Things were slower. And so the way that scientists worked together was they actually went to each other's labs and went to conferences and traveled around. So he was doing that a lot. And actually in 1914, he took a little vacation to Germany before he was supposed to start a new teaching job at the University of Manchester in England, and he got stuck. He had a lot of trouble getting out because World War I had started. Now, he was a professor with starting a young family, so he was not involved in fighting in the war, but he definitely was disturbed by the devastation of the war and understood how it just messed up. He was a very, very philosophical person, and he wanted people to be, to achieve great things. And so he was very disturbed to see that was disrupted and that terrible things were happening instead. So young Niels Bohr wrote those papers, traveled around, and in 1917, so this war was still going on, he moved back to Denmark, where he had, they made a position just for him. And he started an institute called the Institute of Theoretical Physics at the University of Copenhagen in Denmark. That was his hometown, Copenhagen, Denmark. And in 1922, all his work was recognized with a Nobel Prize in physics. So at that age, that young age, he got the Nobel Prize. And he got more and more recognition. And you can see him here at a conference, and you'll see Bohr's there on your right. And you probably recognize that guy in the lower left. It's Albert Einstein. So he got recognized by scientists, and he was very much of a lift while you climb kind of person. And so he he was developing a network of young scientists who he mentored and taught and encouraged. And that's the sort of role he shaped for himself in Europe at that time. Now, at these conferences, he met a lot and made friends with a lot of really influential people. So in this one, he's in the lower left there, all the way to the left, and right next to him is Werner Heisenberg. And then the one woman you see in the front is Lise Meitner. And she really looked up to him. It wasn't easy to be a woman physicist at that time. And she was actually Jewish and in Berlin, at the University of Berlin, and he helped her get out to Sweden. He helped a lot of scientists at that time in the 1930s. Fascism was rising, anti-Semitism was rising. It was clear that Hitler was not going to go away. And Bohr fought for scientists. He worked with the Rockefeller Institute in the United States to fund scientists who were sort of in the shadow of the Nazis to move out and move away and get jobs and placements and fellowships in safe countries like the United States or England. And Lise Meitner got a job in Sweden. So in 1938, Lise Meitner and her colleagues had been conducting research for a while, trying along the lines of Bohr's idea, trying to understand exactly how the nucleus of an atom worked. And they were doing these experiments. She had to leave in the middle of the experiments because of the fascism in Germany. And so they continued the experiments without her, and they got this amazing result. And she helped them interpret it and realized that nuclear fission had occurred. They had hit uranium sample with some neutrons, and they got a huge amount of energy, and then some very different elements were there at the end. And they realized this meant that they had split an atom. They didn't realize it until she told them that that's what had happened. And she communicated with Niels Bohr, asked what he thought, and he totally agreed with her. And it helped him revise his theory of how the nucleus worked. But this was a really big concern to people who saw the rise of Hitler, because they thought, wow, this research is going on in Berlin while Hitler is gaining power, and they've found this great new source of energy. So right after that, Niels Bohr left Copenhagen, and this is a picture of Copenhagen in the 1930s, a drawing. He left there and went to the United States in 1938 to the beginning of 1939 to give a talk on physics in New York. And he talked about the results, the discovery of fission. And this led scientists in the United States to also share that concern about Hitler having this great power. Well, events marched forward, and in 1940, in April of 1940, the Nazis moved into Denmark. Now, this was a different sort of occupation. The Danish retained a great deal of governmental control. They still had their king with them, but they were still under the power of the Nazis, and this did not lull Bohr to sleep. You know, this is a protest at the meeting of the Nazi party of Denmark. So there were some Danish people who kind of sympathized with the Nazis, but by and large, they were against it. But the government tried to keep people from resisting too badly because they didn't want backlash. But Niels Bohr had in his lab the Nobel Prizes from 2 German scientists. They had sent him for safekeeping because the Nazis didn't believe that people needed awards from outside countries. They just needed awards from their own government. So they would have confiscated those medals and melted them down for their gold because they were pure gold. So they had sent them to Niels Bohr, And Niels Bohr had them in his lab, and he worried that they would be found and stolen by the Germans, but also it had the names of those scientists on the medals. And so they would have been arrested for sedition and put in camps. So he had to get rid of them. He knew they would dig up the garden and everything. So he did a really smart thing. He dissolved them in aqua regia, which is a mixture of nitric and hydrochloric acid, and dissolved them. So they were just these yellow flasks of solution on his shelf, and the Nazis had no idea they were there. Then after the war, they precipitated, got the gold out of the solution, and they were able to remake the medals. So he was involved in that and other ways in the resistance. Now, the Germans never were able to get the Danish to expel their Jews, to identify them and ship them out. The Danish police actually were so antagonistic towards German control that eventually all of the Danish police were rounded up and sent off to camps. Most of them survived the war, but that's how extreme it got. Now, if you look at this map of Denmark and Germany and Sweden, you'll see that Denmark is like a thumb on the hand of Germany. If Germany's a fist, it's the thumb sticking up. And that lower border, that southern border of Denmark, is kind of a controversial area where some Germans thought that territory should have been Germany. And that's where most of the people that went along with the Nazi occupation were from that southern area. But they went up, the Germans went up, and one of the reasons they wanted Denmark was that Norway's right there, and it was part of their path to getting to Norway, which strategically they wanted control of. But they had left Sweden alone, and Sweden was technically neutral. But if you look at that map, you see Copenhagen is really close to Sweden. So in September, October of 1943, the Germans had had enough. They were tired of strikes by the Danish people, by their refusal to turn in their Jews, and they decided they were just going to crack down. Bohr never thought of himself as a Jew. He was an avowed atheist, but his mother was from a Jewish family that had been there in Denmark for a long time. Denmark had been a bit of a haven for Jews of Europe. They could come there and be relatively left alone. And so there were something like 10,000 Jewish people in Denmark at this point. He was considered Jewish by the Nazis, even though he didn't consider himself Jewish. So the Danish resistance heard that they were coming to round up. They were afraid of targeting Niels Bohr because he was such a great international figure, but they were just going to target all the Jews in a neighborhood, and that included where he lived. So they got word of this. He hid out in a potting shed near the harbor with his wife until night descended, and then they went across to Sweden in a fishing boat. Now you can see there, Helsinki is very much closer, but Copenhagen itself is just a few miles across the ocean water to Sweden. And so they went in a fishing boat. This is actually a fishing boat that's at the US Holocaust Memorial Museum in Washington, DC, because this escape of Jews to Sweden was very famous. And the day after they got there, after Niels Bohr got to Sweden, he left his wife there at the harbor waiting for their sons to come across, and he headed north by train to meet the King of Sweden, where he convinced the King of Sweden to officially announce that they would give asylum to any Jews that came there. So almost all the Jews of Denmark survived and were not sent to camps. And this was such a big dramatic event that they have an exhibit about it at the US Holocaust Memorial Museum, and that boat is there in it. So that's the kind of boat they had. And that's what it looked like, just people gathering on small fishing boats just to go across 5 to 20 miles of water to get to Sweden. When Bohr got done talking to the king, he was flown to England and joined their version of the Manhattan Project, and then to the United States. When he got to the United States, he joined the Manhattan Project, but he was more of a theoretician and not so much of an engineer. And so he really just mentored the scientists, talked to them, helped them work through their conceptual ideas. But he was an important part of that Manhattan Project. And then at the end of the war, of course, the bomb didn't end the war in Europe, but it ended the final part of the war. But when liberation came to Denmark, shortly before it came to Germany, after it came to France, the people celebrated in the streets. And I love this sign. It says, "Closed due to happiness." So this owner of a restaurant closed his restaurant due to happiness, and some resistance people are guarding it for him to make sure nobody broke in. So there was some hardship from food and stuff, but Denmark got through the war relatively easy compared to other places. But you know, the story of after the war is a story of rebuilding in the nations that were destroyed, both the Allied and the Axis nations. And Niels Bohr really believed in an international community of scientists, and he built up his institute. He helped found CERN, which is a really important research institution that's in France, that's open to all European scientists. And he just became an honored member. And this is a picture of a memorial meeting. He's in the front row towards the center of this in 1963. And so I think Niels Bohr makes a cool story because he was there in the buildup to the war. He was there during the war as part of the resistance. He was there as part of the Manhattan Project. And then he was there in the rebuilding after the war. Churchill and the American government were a little suspicious of him because they knew that he felt like we should be sharing the information about nuclear fission with all the scientists and in the world, and not just the allies. And so they were worried about him as a security risk and put him under surveillance, much like they did Robert Oppenheimer. So I want to go back to part of this story that we talked about, the solutions. So solutions are an interesting thing because it's like that gold. When he put it in that acid, did the gold disappear? No, it was still there. But where did it go? Well, it mixed in and became a solution with the acid. And so we're going to do a little demonstration showing about how solutions work. So I've marked this out. I have just a jar of water here. And you can see that I've zeroed it out so that it weighs 0 grams. Now, as I put salt in it and mix it up, you can see the mass go up because the salt's in there now too, right? But it's going to dissolve in the water. And so sometimes when we describe with regular everyday words what happens in a solution, we might say that it disappears or it melts, but it doesn't really disappear because you could see by the mass that the matter is still there in the solution, but it's just it's interacting with the water molecules so that you can't see it. So there it is. It gets almost all dissolved there.
And while that's dissolving, don't forget, if you have any questions, please type them into the Q&A and Rob will be answering a few shortly.
And so we could put that through a filter now, and we wouldn't be able to filter the dissolved salt out with the filter. The only way to get it out is to let the water evaporate and leave the salt behind, or to add in another chemical that would interact with the water better. And that's how they got the gold back, is they put zinc into that acid solution and the gold precipitated out. So that's just a little cool science bit to illustrate our story. You see we have 13 grams of salt there, but we don't really see it. It's invisible because it's interacting with the water molecules. All right, now who has questions for me?
All right, Rob, it looks like we're getting a few in. So Dawn wants to know, what chemical did he put the gold with first when he hid the metals?
He put it into this solution that's been known since before science was really science. They were called alchemists back then, and they called this solution aqua regia because it could dissolve gold and platinum, which were considered kingly metals. And it was hydrochloric acid and nitric acid, and you don't want to mess with it. It's really nasty stuff. And he just put the metal in there and just kept stirring, and it got hot and the gold just disappeared. The solution is a really funky, yucky looking thing. At the end, he put in some zinc, which is another kind of metal, and the gold flakes started precipitating out. And then he filtered the gold flakes out and got the gold and sent it up to the Nobel Committee, and they remade those medals. He didn't have to hide his medal, by the way, because he had donated. This is another very Niels Bohr thing. The Finnish people suffered greatly being squished between the Russians and the Germans during World War II, and he had donated his medal to be sold for Finnish relief to help the people of Finland in this terrible crisis.
Awesome. Thank you, Rob. And looks like we have one last question. Does the museum, do we have any lessons or exhibits about science in World War II, since we're talking about it?
Oh, I'm so glad you asked that, because that's my whole job, is to do science stuff with World War II. So on our website, you'll find Real World Science. It's on the, we'll add a link to it on the Facebook page, or maybe we'll put it in the chat so that everybody can see it. It's Real World Science at the World War II Museum, and it's a curriculum for 5th through 8th grade students where they can learn all about the science connected to World War II. It starts with the World War II story, and there's actually a bunch that are related to Niels Bohr, where students learn about elements and the periodic table, so that they can understand how nuclear fission occurred. And they involve easy to get stuff like beans and mason jars. So it's stuff you could even do at home. We have a STEM gallery. We have a bunch of online videos about STEM. If you search our distance learning history, we have some stuff about cool big stuff and how it was innovated, like a 18-ton person mover that floats in the water. And we have an amazing Manhattan Project electronic field trip. So that's great. Well, thank you very much. This will be recorded, and so you can see it later, show it to your class later. And please email us or contact us if there's anything else we can do to help you learning in your classrooms or teaching your students. Again, my name is Rob Wallace, and signing off from the National World War II Museum.